Hello, welcome to Engineers Mindset. So in today's class, I'm going to be talking about fundamental and derived quantities. Okay, further on we'll talk about dimension analysis and how to actually dimension physical variables. But first of all, what are fundamental quantities? Fundamental quantities are those quantities whose value do not depend on any other value to be defined. Okay, so they actually do not depend on any value to be defined. So we simply call them fundamental quantities. These quantities do not depend on any other quantity to be defined. For instance, we have mass. Okay, we have mass, we have length, and we have time. So these three quantities are called fundamental quantities. Although when you move over to the tertiary level, you find out that we have more than three fundamental quantities. But below the tertiary level, we have three fundamental quantities, which is the mass, the length, and the time. These quantities do not depend on any other quantity to be defined, so we simply call them fundamental quantities. So you can't actually add two quantities to get mass. You can't subtract two quantities to get mass or length or time. You can't divide, you can't add or whatever. You can multiply different quantities together to obtain mass. So therefore, they are actually called fundamental quantities. Now, the units of the fundamental quantities are what we call fundamental units. Okay, fundamental units. Okay, fundamental units. Of course, like I said, below the tertiary level, these are three basic fundamental quantities that we have in physics. Of course, and at the tertiary level, we have temperature, which is also what a fundamental quantity. Okay. Now, the unit of mass is actually what? Kilograms. Okay. The unit of mass is kilograms. The unit of length is actually what? Meters. Is meters. And the unit of time is seconds. All right, so kilograms, meters, and seconds actually form what we call the fundamental units. So fundamental units are actually what? Units of the fundamental quantities. So these units are actually what? Self-dependent units. They don't depend on any other unit to be defined. You can't add or subtract or multiply or divide different units to obtain these units. So we simply call them fundamental units. The units of the fundamental quantities are simply called fundamental units. On the other hand, we have what is called derived quantities. What are derived quantities? Derived quantities are simply what? Those quantities that depend on the fundamental quantities to be defined. They are simply those quantities whose value depend on one or more of the fundamental quantities to be defined. So we simply call them derived quantities. Every physical quantity in physics, excluding the mass, length, time, and temperature, every other physical quantity in physics are all called derived quantities because their values depend on combination of one or more of these fundamental quantities for them to be defined. So every other physical quantity in physics, excluding the fundamental quantities, are simply called derived quantities. Examples include acceleration. Okay, let's use acceleration. Okay, velocity. You can talk about force. You can talk about pressure. All right, so you can keep on going on continuously to what I can go on continuously to mention as much physical variables as we have in physics, but every other variable outside the fundamental quantities actually depend on what funda outside the fundamental quantities are simply called derived quantities. Now, for instance, acceleration is simply what displays velocity, okay, all over time. This simply gives us acceleration. Velocity itself is simply what? Displacement, okay, all over time. That gives us velocity. But notice now that we have time here, and time is what? A fundamental quantity. We also have time here. Time is a fundamental quantity. For velocity, we have displacement. Displacement is measured in meters, and meters is a unit of what? A fundamental quantity, which is length. So like I said, once we combine two or more fundamental quantities together, we obtain what are called derived quantities. So the combination of two or more fundamental quantities yield what? This other what? Every other physical quantity in physics. So every other physical quantities apart from the three fundamental quantities or the four fundamental quantities are simply called derived quantities, as can be seen here. Okay. Now, the three fundamental quantities in physics, okay, can be used to obtain the dimensions of what? Physical variables or physical quantities. For instance, mass. In terms of dimension, mass is simply called capital M, and in terms of dimension, the length is simply called simply what? L, and the time is simply called capital T. So they three together give us what is called the MLT system of measurements. Okay, give us what is called the MLT system of measurements. MLT system of measurements. All right, so combining the three actually gives us what is called the MLT system of measurements. Now, this system is actually used to obtain the dimensions of physical variables. Okay, the MLT system of measurement is used to obtain the dimension of every other physical quantities, which are the derived quantities in physics. So that will actually take us to what is called the dimensioning of physical quantities or variables in physics. Okay, that's actually called dimension analysis. Now, what is dimension analysis? Dimension analysis is simply what? The combination of the MLT system of measurements to obtain the dimension of physical variables. The combination of the MLT system of measurements to obtain the what? Dimension of physical variables. For instance, let's talk about velocity. Okay, we know velocity to simply be what? Displacement. Okay, all over time. Okay, so velocity actually means displacement all over time. So dimension of velocity will simply give us now, of course, we know that displacement measures what? The length of an object or distance covered by an object in a given direction. Now, and that simply means displacement can stand for what? Length. Okay, because the unit of length here is meters. Unit of length is meters. Okay, unit of mass is kilograms, not forgetting, and unit of time is seconds. All right, so it means now that length, which is measured in meters, displacement is also measured in meters. So which means the dimension of displacement can simply be replaced as what? L. So we simply call that capital L all over. We have here time, and we use capital T to represent time from the MLT system. So we simply have all over T. So this simply implies that the dimension of velocity is what? We can rewrite this as simply L T to the power of minus 1. So you simply have what? This. So the process of combining what? The MLT system of measurement to obtain dimension of other physical variables or or derived variables, sorry. The dimension of other physical variables or derived variables are what we call dimension analysis. Okay, so we actually have to what? Combine the what? MLT system of measurement and then obtain the dimensions of physical variables. That gives us the dimension analysis. So velocity is simply what? LT minus 1. This is a dimension analysis for what? Velocity. Let's try acceleration and see. Acceleration. Okay, and acceleration is given as what? Velocity all over still time. So you simply have this. So acceleration A is now equal to, already we've obtained the dimension of velocity, and that simply gives us LT minus 1. So we can simply call that LT to the power of minus 1 all over time. The dimension of time from the MLT system of measurement is simply what? Capital T, okay, all over capital T. Of course, this becomes LT minus 1. Since here is also dividing by T, we can break that and it becomes T to the power of minus 1 from indices. So we simply have that acceleration A is now equal to LT. Okay, so from indices, once two variables are multiplying each other, having the same base, simply pick one of the variables and add their powers. So we simply pick one, T, we add the powers. I have minus 1 here. I also have minus 1 here. So this simply gives me what? LT minus 1 gives me minus 2. So this is simply what? The dimension of acceleration, simply LT minus 2. Okay, so let's try about 2 more examples and see. Okay, now let's try for force. We are given that force is actually mass times acceleration due to gravity. Okay, all right, so this simply implies that force is now equal to the dimension for mass. We've obtained that here is simply capital M. So we simply call that capital M, okay, times dimension of acceleration. We've already obtained that in the previous okay, just look up. We've already obtained dimension of acceleration, okay, and we'll obtain that to be simply LT minus 2, not forgetting. So this simply means that the dimension for force itself is simply what? MLT minus 2. So we simply have this. So that gives us the dimension analysis for force. Okay, let's try for pressure. So let's try for pressure. And you know pressure is simply what? Force all over area, and area is actually measured in what? Length squared, that's meter squared. Area is measured in meter squared. So this simply means that pressure is equal to, we've obtained the dimension of force. Dimension of force is simply LT minus 2, which is what we have here, all over area is actually what? The unit of area is a meter squared, so which means is a multiple of length and length. That gives us what? Meter squared. That the unit of length stands for meters, which is what? L times L, and that's simply what? L squared. So for area, we'll simply have L all squared. Okay, so from here now it's obvious one of these can strike one of these, so I simply have to pressure P is now equal to, this becomes M, so one cancels one of these. I'm left here with T minus 2 all over here. Now I'm left with what? Simply what? L, because one cancelled one here. So if I write this now in indices, it becomes L to the power of minus 1, since it's division, T minus 2. So that becomes the dimension of pressure. All right, so simply the combination of the MLT system of measurement to what? Obtain the dimension of physical variables actually gives us what is called the dimension analysis, or dimension of those physical variables. All right, guys, I think I'll pause it here. In the next videos, we will start dimension analysis of what? Difficult functions. Okay, we'll start dimension analysis of difficult variables or physical quantities in the next videos. I hope you find the video very interesting and helpful. Please, if you do, I would like to get your thoughts in the comment section. And if you're new to the channel, please don't forget to hit the subscribe button to keep getting updates when content such as this comes out. I will see you in the next video. Thank you.